Okay, good morning, everybody. How's everybody doing this morning? A little groggy, a little tired, ready to go home? All right, well, welcome. My name's Quint Van Diemen. I'm the Business Development Manager here at AWS for our Identity and Directory Services. And I'm going to hopefully do it like, I hope that your brains are going to operate on a last in, first out mode here. So I'm going to try to jam in as much super deep identity information for you to take home and be able to pop off the top of the stack on Monday morning. So what are we here to talk about today? So I've had the awesome luxury of, or opportunity of being able to do an identity-focused talk at reInvent each of the 4 years. But this year, I really was excited to make it a 400 level so we could really go deep in things. I think hopefully I'm going to show you some patterns that are pretty advanced. And more than just showing you the feature, I hope to show you how you can combine some of these features, sprinkle in a little bit of code, and really hit at something that's really impactful for you. I'm also going to try to be very prescriptive for you, right? I think we AWS have gotten better at this over the years. But rather than even just going to the level of giving best practice, I'm going to try to go about a little bit of decision tree kind of walkthrough such that we can help you approach common use cases that you're probably facing in your environment, and then walk through some key breakpoints or key decisions that are very specific to you as a customer that helps you arrive at a very tailored solution. And last but not least, again, being a 400 session, we're gonna go way down deep into code, right? So if you are the type of identity professional where a little bit of Python, a little bit of JSON, a little bit of YAML is terrifying to you, I will not be offended. But now is probably the time to leave, or the rest of this is gonna really make your head hurt. Okay, so the kind of before we dive into the fun meat of things, I want to start with just one disambiguation. And I do this because as I go around and talk to lots of great customers such as yourselves, I find that this is not always terribly obvious, right? So what we're here to talk about today is going to be identity the subject, right? So that is authentication, authorization, audit, governance, etc. for your cloud workloads, right? Whether that's the AWS platform, applications on top, the infrastructure in the middle, the whole 9 yards. And we'll look at that more deeply in a second. That very much includes, and certainly the most foundational component of that is AWS IAM, the service. Right? That is the service that uniquely authenticates and authorizes all of your AWS API calls. So very powerful part, but just want to make sure we're setting the aperture at the larger subject for today. Okay, so in most of my talks, I tend to talk through metaphor, talk through analogy, right? I find it very useful to help make some of these topics that can be complex at times a little bit more approachable, and just gives us a good mental model to work through. So this year I chose a cake, right? And hopefully you'll bear with me a little bit as we play it out. So the bottom layer of this identity cake in AWS is, again, certainly the AWS platform, right? This is where we've got to get our cloud builders into AWS. To do, start EC2 instances, create S3 buckets, etc. Right? So we got to, and that's generally, those are operations done in the management console, the CLI, API, etc. The next layer up of the cake is what I think I refer to it as the infrastructure layer, right? This is where you're connecting to operating systems, you're connecting to database engines, right? There's some unique nuances of this infrastructure layer when it's in AWS, and that most of our compute components have identities themselves, and we'll explore that a bit, right? And then finally, the layer on top, right? Once the cloud builders provision that infrastructure, we deploy our code. Obviously, at the end of the day, the real purpose of all that is to run applications. And we've got to make sure that we get our users, be they our internal users, our customers, our partners, etc., into those applications, right? And so this is really how I'd have you look at identity, the full totality of identity in AWS, is these kind of layers for all those types of users. Now, again, maybe perhaps I kind of found it a little humorous to think about what folks would think about when I posted these slides to SlideShare, right? Like, what in the world is this crazy person doing, putting pictures of cake up there in an identity talk? But I think the metaphor is a very good one, right? But it has changed over the last particular 18 months. 18 months ago, I would have said to you that it really was a layered cake. The way you approached identity at the bottom was fairly distinct from the way you approached identity in the middle, and fairly distinct from the way you approached identity on the top. We gave you tools, we gave you services in each of those layers, but they were ultimately fairly independent. Today, I'm going to show you how these days it's a little bit more like a tiramisu, right? There are still some layers in there. There's still some things you can tease out, but the lines are blurring. And I think they're blurring for the good, but it's important that we kind of recognize that. All right. So now to kind of, to help solidify that, right? Let's look at a service like EC2. And again, this is something that I find is very important as you're considering how you do identity in AWS to understand planes of access, right? If we look at a service like EC2, you've got your control plane, how you stop said EC2 instance, and that is an AWS API, authenticated by AWS credentials. Typically speaking, your connection to that resource, right, in this case you might use SSH or RDP, is over the data plane. You're connecting to that instance over a network connection, right? And especially, again, 18 months ago, I would have told you that these were different paths, credentials, and protocols, and you need to be mindful of that. We're going to see today that there's definitely now kind of an asterisk on that last one that we need to be mindful of. It'll be your choice, but some exciting things nonetheless. That is very distinct from a service like perhaps DynamoDB, right? Here we've got the control plane, how you create a table, the data plane, how you put or get objects out of the table. And in this scenario, it's always been a unified approach. Both of these mechanisms are AWS APIs, therefore authenticated and authorized by AWS IAM. All right. Okay, so hopefully that was just a super fast grounding, and now let's jump into the good stuff, right? So the first topic I want to go through is, again, let's dive now further into some details on that bottom layer of our cake, how we do identity for the platform layer. And I almost didn't do this section of my talk because I've done this particular topic quite a number of times in summits and reInvent talks past, but I still find that there's a lot of folks struggling to figure out how to best get a whole bunch of cloud builders strongly authenticated into roles across a large fleet of AWS accounts, right? This is not a new problem. It's been around for a while, but there still generally tends to be some confusion because there's a lot of awesome ways to do this, right? And we believe in giving you choice in how you go about this. I'd say quickly your options today are these three in principle. On the left, you've got an option that's been around since, I believe, 2014 at reInvent, where you can use a SAML identity provider that you may already have in your environment to bridge through to AWS IAM directly, right? The middle option there is where we've taken essentially that pattern and said, managing identity providers isn't for everybody. It's complex. It's identity goop that not everybody wants to deal with. So we just passed reInvent. It just missed the cut last year. We announced AWS SSO, which is essentially the same pattern, but where AWS manages the identity provider. And because we do so, we also can do some neat bells and whistles in taking more of the identity within the platform off your plate. And the last option is where you build a custom broker, right? And this is probably the original federated option into AWS, where you get the benefit of having it be whatever you want. You could do any complexity of authorization and authentication you need to, but the kind of the challenge here is that you own everything, right? So let's get prescriptive, right? How do you rationalize through which of these three options is best for you? Now, I've had to kind of, for the sake of fitting it on a PowerPoint slide, simplify this a bit from the version I kind of walk around with day to day. But let's say, again, we're facing that basic challenge I outlined. The first decision point I think you need to make is, can you purely make the authorization decisions, who is allowed to access what role, purely based on the notion of groups or attributes, generally in a back-end directory? If you can't, the option is clear, right? You've got to go to a custom broker. Some folks are doing really elaborate stuff about very contextual information in terms of making these authorization decisions, but if you're going to reach out to all sorts of those various sources, you're going to be in the custom broker world. If you can do all those decisions based on that, your next breakpoint is do you already have an existing SAML infrastructure in your environment? If you do, that's great. Just leverage it. Like, this is a pattern that's been around for a long time. It's really well oiled. It's really clean, and you really know you're going down a well-trodden path. Right? If you don't, the third kind of breakpoint that I'd have you come to is how many accounts, AWS accounts, do you reasonably forecast in your future? If it's under approximately 20, I would say your best option is go to AWS SSO. Right? It's basically one button, turn on, you're up and running. Now, it's important to know 20 is not a limit. It's just, I find that to be kind of the scale at which management of these entities through AWS SSO kind of is at its sweet spot. Now, that will certainly change in the future, but for right now, if you were in the realm of over 20-ish accounts, again, not a limit, just kind of Quince approximation, I'd have you go back to that very well-trodden path of SAML, right? Okay. So now, again, I wanted to touch on it, but I didn't want to dive super deep. If this is a topic that you want to explore some more, the QR code that's there on the left is a workshop that we did a couple of years ago that really drives soup to nuts all the way through the SAML story. And obviously there on the right is AWS SSO, a way to get started. Okay. So let's dive into something a little bit newer and a little bit more interesting within the platform layer. And that's, I think boundary policies is probably the official name of the feature, but I think of it in terms of IAM delegation. The quick backstory here is before July of this past year, there were a number of identity actions in AWS that were very godlike permissions, right? The ability to create roles, attach policies. If you gave somebody the ability to do so, you couldn't constrain what permissions they were going to put in those policies, right? And that was just the mental model of AWS IAM. But the effect of that is if you wanted to empower your developers to create roles for their instances or roles for their Lambda functions or what have you, you generally had to still keep that as a centralized function, which meant friction, it meant slowness, it meant bottlenecks. Now what you can do is, we released again in July, a feature called boundary policies. And that essentially allows you to offer those previously godlike permissions downstream to your developers, but it still allows you, the central team, to essentially put a bubble around the set of possible permissions that they are allowed to use, right? Now, the way it essentially works is, and you've seen this in many cases in the AWS identity space, is it's a full intersection logic. You, the central team, generally provide the boundary policy, right? What they're allowed to do. They get to you've now delegated them the ability to create the permission policy. But when the API call goes into AWS, what's going to succeed or fail is the exact intersection of those two. So they can put star on the right, and nothing is going to succeed unless it's allowed by the boundary policy. And again, this is a big deal because now we can unleash those developers. We can not have to have all their IAM needs for their applications come centrally. So let's see how this works, right? The first step is to actually create the boundary itself. Now, don't think about a common point of confusion here is this is not where you're constraining the developer's actions. You should not be thinking about this like I should allow them to start and stop EC2, or create S3 buckets, so on and so forth. This is about the actions that you're going to put in these boundary policies are the actions that you want to constrain in the roles they create, right? And so it's going to be things like puts and gets at S3, DynamoDB retrieval operations, SNS, SQS, etc. So the example here is we're going to constrain this particular the delegated roles to be able to only do some basic DynamoDB operations in the EU Central 1 region. The second step, again, still on the administrator side of things, is you're going to give permission to that developer, again, in the policies attached to their normal role, the ability to do those, again, previously very sensitive operations, create role, attach policy, and so on and so forth. But you're going to add a condition where they're only allowed to do so if they themselves specify this boundary policy, right? And then the last step is, you've got to, after they've created a role, they have to be able to use it, right? And so the third kind of logical permission that you need to offer out to them is the ability to pass that role, the ability to use that role. Now, it may not be terribly obvious in the JSON here, but you'll see that I've used paths within my resource line there, right? And I think that pathing is probably one of the most undervalued points of authorization within AWS. It's not, ironically, it's not supported by the console, but if you're building your roles with CloudFormation or Terraform or by whatever other automation you might want, it's a really awesome way to kind of segment your roles out into logical spaces. And then the last step is the one on the user side of things, right? And generally there's nothing that needs to change, with the exception of they add one extra condition or one extra parameter to the creation of their role, where they themselves specify the boundary policy. And this, to me, is the best, a really nice way to, this comes all full circle, is because the developer, it's transparent to everyone. They understand that they are operating within this boundary, and so they're not going to get confused why their API calls are failing when they've specified ***, right? You can also do, permission boundaries are now supported by CloudFormation as of 2 weeks ago. Certainly same thing. I've showed it with the CLI here, but same thing is possible through CloudFormation. Okay, so that release really nailed probably the biggest challenge in this space, right? We've unleashed that agility. We've let those teams run at the speed at which they're able to run without fear that they're going to blow the guardrails off the road, right? But there's still kind of a second problem that's embedded in this whole space, is that writing IAM policy language effectively, well-scoped, least privilege, all those terms that we know and love, is still something of an art, right? We're working on making it better, but it's definitely something of an art. Generally speaking, the developers that we've now cast into this world haven't had any experience doing that by and large, right? And so if we don't make it super easy for them to do the right thing, certainly my assertion is we're going to end up with a lot of policies that they've authored that just say ***, and I'll let the folks that did the IAM boundary policy take care of all the hard goop, right? And so what if we could have a world where instead of the developer having to write all this JSON, which you can see I obviously struggled even with a simple policy to condense it down to where it would fit on one slide, what if they could write something like this, right? Again, what we're going to use here is a combination of a relatively new feature called CloudFormation macros, right? In this case, we're going to do a transformation. Think of CloudFormation macros as a preprocessor on your CloudFormation templates. They still need to specify some basic elements about the role, right? They still need to get, we need to know whether it's for Lambda or EC2 or what have you. But then, instead of specifying all the goop of that policy language, what if they could just describe permissions in a way that's very human-oriented, human-centric? I want to read to this bucket, or read and write to this DynamoDB table. That, to me, seems like a language that developers could very quickly understand and very quickly operate with. So let's see how that might work. So this happened the other day. Can we flip over to the other screen, please? Why is it locked here? Yeah, I don't have permission. I really don't. It's blinking red like you are not going to switch this screen to save your life. No, that's not the right one. Guys, can I get the demo computer up on the screen, please? Sorry, this is a Friday morning moment. I apologize. Yeah. So it's blinking red and totally frozen. Ah, I talked too long. Computer went to sleep. There we go. Wow. Anybody got any good jokes?
Maybe try rebooting?
Yeah. Bill Gates it, right?
Is there a tech guy in the house?
I don't know. I could use one.
We can all
It's actually Linux, even better. Touche. Yeah. All right, here, we'll unplug and replug. We'll try it. Well, that'll be the display version of Bill Gates. Yeah, there should be. All right, we at least got green on the screen now. Hey, all right. That only took a minute. All right. And I did not have that minute to burn. Literally, when I did this on Wednesday, we went right to the end. So, okay. Apologies for a little tech confusion there, right? Okay. So the first thing I'm going to do to get this started is I'm going to actually log in using SAML Federation, like I described earlier. All right. And again, what I'm kind of doing here looks like Voodoo grabbing a CLI token over SAML, hit that QR code, right? So I'm going to go into my bounded developer role, and what just happened is I fetched an AWS credential tied to me through SAML. So now I'm always terrible at typing and trying to talk at the same time. So I do these little helper scripts, right? So what I did here is, but to make it so that you knew that I wasn't cheating, I just kind of echoed out what I was doing. So you can see I used my SAML profile, and I did a deployment operation on this example template, right? You do have to use the deploy step when you're using these macros rather than create stack, which you might be used to again get that kind of pre-processing operation going on. Okay. So now, while it's baking, and we'll show you the end product in a second, right? I think and I showed a fairly simplistic example in the slides, but here's what's kind of building in the background, right? It's the same pattern, just a little bit more complicated. I've got a handful of resources. Some I've done read-only, KMS keys, some parameters in parameter store, so on and so forth. What I'd have you observe here is that there's also this SQS permission, right? And that one's going to apply into the boundary policy that we'll look at in a second. So this this little snippet here is 28 lines. By contrast, what the original file that I kind of started with, and I did this one in JSON just to make the contrast particularly painful and obvious, right? This is, let's see, 258 lines. So somewhere on the order of 10x reduction in policy size, at the same time, at least in my opinion, making it radically more simple to understand and view. Okay, so now let's flip over, and we're going to go into the console. Again, you're seeing me here sign in to my identity provider the same way, but this time, instead of doing it through the CLI, I'm doing it into the console. I'll choose that same bounded developer, and let's drop in, right? And let's see kind of how this magic, this voodoo works. Again, what a CloudFormation macro essentially is it's sending your template to Lambda as a preprocessor. All right, so if we go into Lambda, check things out, here we go. Oh. So this code, and I'll show you the link in a second, I've already submitted a pull request into GitHub where this is going to go into the bucket where we have all our CloudFormation macros. But it's basically two simple Python files. Now I've started here. You could make this a lot fancier with perhaps where we store some of these policy templates. But the first function is really easy, or the first part of code is really easy. And let's see if we can make that actually bigger so it's quasi-legible. All this is really doing is it's receiving the template, it's iterating through all of the entities in the template, and it's just looking for the ones that are IAM roles. Finds an IAM role, it sends it to the expansion function, right? And the expansion function, all it really does is it's going in and it's taking these, again, what we defined before was an action group, read-only, read-write, and we can infer the service from the resource that is attached to it. And then it's essentially stored in this other file are these templates for what a good policy for read-only for an S3 bucket might look like, right? So this is where you, the IAM author, get to do all the good hygiene that the developer probably would have really struggled to do. I've kind of just taken some of the default templates or the default policies off, out of our managed policies. But the trick is that we just put in these tokens, right? Particularly the one for resource. And what ultimately the function does is it replaces that one little line with this big snippet, substituting in the resource for kind of the token here, right? And then if we go back and we look at how it turned out in CloudFormation, right? And that's, I've taken a crack at this basic problem space a number of times, but what this launch of CloudFormation macros really enabled here in this space is to be able to give the developer an easy tool up front, but to have their outcome be ultimately at the end of the day a true raw native CloudFormation template. So there's no abstraction, there's no goop in the middle. All right, so if we look, and let's just go and look, the one that I baked is already here done. And all you'll notice different now is that it'll give you the option to view the original template, right? That had kind of my nice little shorthand notation. But you'll see afterwards, and again here they decided to throw it back at you in JSON just to let you know how painful or all the pain they saved you. You see the glorified exploded version, right? But in my mind, this is a really neat way to let again those developers have good hygiene on their side of the equation. All right, so let's before we look at how then that might be applied, how the developer might use that role they've just created, let's just quickly kind of inspect the other half of things. Again, what made this all possible was the boundary policy, right? So if I go in, and if you remember in the role I built, one of the permissions that I called out were the SQS permissions, right? So here is the boundary policy that I've put on myself here. It's again got fairly common operations. I'm going to do some stuff with SSM. I need to decrypt the parameters I'm getting out of parameter store, so on and so forth. And there's a number of other things that I've kind of rolled into here that are useful for me as the developer to be able to do. But I've decidedly not offered them myself the ability to do any SQS operations. Right? And then again, after I've got that boundary policy in place, I give my super duper powerful privileges, but I make sure they do it within the boundary. Okay, so let's see how that plays out. So first, I'm going to we'll start a new little window. I'm going to go to the little demo app. I created this in Flask. It's just kind of, because I like Python. This is generally very, making demos of things that succeed or fail interesting is hard. So bear with me, right? But the first call that this application is doing is one that was inside the boundary, right? So we went out to DynamoDB and we got our 3 kind of fun flavors of cake back, right? The one that was outside the boundary, right, and I'll show you this in a little bit more gory detail, was I tried to push some information to an SQS queue, right? You saw where I, the developer, very clearly tried to give myself the ability to do so through that role, but because of that intersection logic with the boundary policy, I get denied. And then even if the developer should happen to do kind of the craziest thing going. Let's go into IAM. Let's go into my roles. Let's find the front end role that's kind of underneath that application. All right, and let's attach some policies. We're going to go just right to the jugular. We're going to go administrator access, right? All right, so let's let's list our instances. Let's grab one of these front-end servers. Let's SSH to our Bastion host. All right, let's SSH over to the front-end server. And so now, again, I in that last step, attached like full admin permissions to the role that this is operating as. And so the first, if I can type, see, I can't type and talk. All right, so the first kind of test is the same kind of CLI version of what I already showed, right? Here was that role that I modified, just doing an STS get caller identity. I'm successfully able to push to S3 because both of those were within the intersection, but my SQS call gets denied. And that's certainly well and good, but the one that everybody was always worried about is, again, I attached permissions that were inappropriate, I drop into the box, and I try to execute this highly privileged operation, in this case creating a user, and I clearly get denied, right? So even though full admin permissions were well constrained, and everybody's happy. All right. Cool. So I mentioned we've already got a pretty good repo of these CloudFormation templates out on GitHub already. The one that I just showed you, should you want to play around with it and experiment, the pull request has already been submitted. I don't own getting it merged, but you should be able to see it out there. I do know the gentleman that owns getting it merged, and we're going to work to get that rolled in as soon as possible. And if you can't take the pictures fast enough with the old QR codes, all these slides are going to be available on SlideShare. I don't know the exact number of days, but very soon. All right, so if that was a couple of quick highlights and hits in identity for the platform layer, let's now move up to the next layer of our cake. Let's go up and look at identity in the infrastructure layer. As I alluded to a little bit, part of this equation is a problem that, or not a problem, but is a space that you've been operating in for a while. How do I properly authenticate and authorize users into operating systems, into databases, et cetera? And we're going to explore how that is maybe similar or maybe the same in AWS. And then the other wrinkle is a little bit of what you just saw me doing, right? I had the compute components in AWS that you build your applications on generally have identities themselves, right? So let's look at both of those. All right. For identity for the infrastructure, again, you've got lots of options here. And probably what makes sense for you depends on where you are in your journey. If you're just getting going and you're migrating a lot of traditional apps to the cloud, you probably just want to stick with the traditional approaches that you've been doing and probably are very good at in this space, right? Domain joining instances, or using SSH, keys and proper key management to connect to these instances is a very valid pattern that is honestly barely different in AWS than it was in any data center you've come from. Now, a lot of times, especially at reInvent, we also, at the other end of the spectrum, we talk about the utopia of no ops, right? We eliminate this problem because nobody ever logs in. The infrastructure is immutable, all these great, wonderful things, but at least in my travels, I find that is a journey that customers need to get to over time, and I'd also have you think about it not always be a binary decision. Sometimes the cloud-native new digital marketing applications might really be able to get to no ops fairly quickly. The application that we migrated that's been rusted into the data center for the last 7 years and nobody has a source code for, maybe it takes us a little while to get there, right? But again, I alluded to this tiramisu factor. What has emerged as a really awesome kind of new option is the notion of IAM-based auth for infrastructure. Now, rather than kind of blow through the word slide here, right, I'm just going to hit a couple of highlights. The advantages here is that it smells and feels a little bit different for each of the services that it supports. But by and large, what you're doing is you're taking your IAM credentials and you're using those to derive an ephemeral credential that you might use to connect to whatever resource that is. And we're going to see a couple examples in a second. It allows you to codify who has access to what for your infrastructure in the same policy right adjacent to who can access what S3 bucket. And it really eliminates a lot. I mean, there's eliminating any form of long-term credential, particularly ones that are powerful like database root passwords, like domain joining credentials for EC2. These patterns allow a lot of those to be retired, which is a major uplift. All right, so let's see how this might work. All right, much better switch over that time. All right, we're improving. Okay, so in the first demo you saw me do just traditional, I SSH to a Bastion host, I SSH then over to the front-end server that I was interested in, very traditional way of doing so, right? So now instead, let's back out of said instance and let's list the instances again. Now, I guess before I show this, I'll show one other part of the permissions that I've given myself. And what I did here is I gave myself the permission to start session to instances that were tagged as front-end servers, right? And here again, this is where I'm codifying my authorizations to what I can connect to. You can do it per instance, you can do it per set of instances, you can do it based on tags. Kind of the world is, lots of different choices there. But then once I've got those authorizations, now I grab my instance ID that I want to connect to, and with my little helper script, again, making demos of logging in to things interesting is sometimes tough. But what I just logged in there, essentially no SSH key, straight to the instance. Now, those of you that are astute and have been around the Linux and Unix world for a while, note that I just dropped into a pretty powerful shell on that machine, right? That's a root level shell. We're going to get better at this over time, give better granularity for what users you can drop into, and so on and so forth. But the real upside, the real kind of amazing thing about this to me, is that port 22 is not even open. Now, we talk a lot in the security world about reduction of surface area and things of that nature. What this feature allows you to essentially do is turn off SSH. That is a really, really powerful thing. All right, so let's see what that looks like, the equivalent feature for a database. Now, the one for Session Manager, again, what it's using there is a WebSocket in lieu of an SSH connection. For RDS, it still is a kind of a traditional database connection. So I do actually have to have network path to the machine. I'm going to still rely on that Bastion host I had a second ago to tunnel the port to my local machine just for good sanity. And then I'm going to connect to my database instance. Now, again, logging in, not super interesting, but when you think about what happened in the background there, it really is. The way IAM authentication for RDS works is you generate, there's an API call, generate DB auth token. What that's doing is it's taking your AWS credentials, SIG-v4 signing with all the great cryptography and API call, and submitting that signed API call as what is approaching 1,000-character, one-time ephemeral password. Right? The only thing I needed to do in RDS was essentially turn it on, and then I do need to essentially pre-provision a user and allow them to do whatever operations I want within the database. But yeah, and then at the end of the day, I use that token. RDS takes that and is able to verify the signature, essentially then verifying my password, and life is good. Okay. So we got a number of services that support this general pattern today, right? I showed you the first two. Redshift also supports a variety of these types of mechanisms, and more to come. All right. So now let's flip over, and again, we looked at this a bit already, but the base primitive in kind of the notion of identity of the infrastructure is a role, right? And so just as a super fast refresher, I attach a role to my running operating system. My code knows how to go into the metadata store that's there, draw out those credentials, and I can seamlessly, without ever having to plumb any credentials or rotate any credentials, I can get those access to those resources. AWS behind the scenes, without you having to do anything, much less take a change window, rotates those, I believe it's every 6 hours on your behalf. Right? And we got similar features for Lambda and ECS. But while that has been a really great tool for you to use in your environment for a number of years for rotating your AWS credentials, that's not generally the only type of identity that your application or your infrastructure layer needs. The most salient example is you probably are connecting to relational databases, and so or third-party APIs, right? And historically, we've had to have the DBA create a credential, and they do the double top secret back alley exchange, where they hopefully encrypt it, but maybe not. Get it over the developer. They've got to do the magic of shoveling it down to the instances, and then when it gets there, it gloriously sits in a plain text file, unencrypted, right? And nobody ever touches it for the next year because they're scared to death to rotate the thing. So how could we do better? At the San Francisco Summit earlier this year, we released Secrets Manager, right? And so Secrets Manager starts with that same basic story. It starts with originating kind of your base AWS credentials, as you always did before. But now, what we're going to do is we're going to take a service and we're going to load in a credential to the resource we want to connect to, in this case, RDS, into Secrets Manager. Now, that might still be a human doing that job, or actually, just in the last couple of weeks, we released the features such that you can embed, instead of embedding a database password in your CloudFormation template, you can just specify a path where you want us to store the password, the randomly generated password, in Secrets Manager directly. Then the first call, now instead of the first call being to the resource you want to connect, first call is to Secrets Manager that returns database credentials and the connections established. Now that part of the plumbing is interesting, it's good, right? It gives you a lot of strong authorization around those credentials. You don't have to take care of wrapping them up in KMS and shoving them in S3 and doing all of the sorts of getting them down to your code securely. But the real magic here is the rotation, right? I kind of jokingly said that like no one would touch their database password because they were terrified to rotate it. What Secrets Manager, its real special sauce, is that we at Amazon have been managing password rotations for databases at scale for a really long time. We took all of that intelligence about how to do it so reliably that no one ever thought about it and rolled it into the service. And what you get by the combination is essentially auto-rotation for all your credentials, right? And that's a powerful thing. So let's look at that. All right. So in my handy little test application here, right, one of the things I've got is essentially just the old way and the new way, right? I'm probably, for time's sake, not going to go ahead and show you under the hood, but the old way, I have a database comp file, right, that's got the clear text password in it. It's real easy to connect. The new way, essentially, I'm using the boilerplate code that Secrets Manager gives me when I store the password. Using this, if I, let's see, so I've still got my little tunnel up. If I go ahead and I do the operation once a year, you know, that everybody always dreads, and I update the old way password, right? Now the DBA is happy, he goes off, he's checked out. But clearly, in the time until I can plumb that new credential down to my app, I've just caused an outage, right? I've just broken things. So how could we do that better with Secrets Manager? All right, let's flip over here, and I'm going to use one little handy script to kind of watch the rotation in the background. You'll notice here that the user I'm connecting with is app user 1, and if anybody wants to take note of some really crazy stuff in this password so they feel that I'm not duping them, there it is, right? And then I'm going to instantly rotate that secret. Now it's going to take about 10 seconds or so, by and large, if the Friday demo gods are working with me. And what it's doing in the background is a very elaborate state machine, such that it's taking a root password. You're going to see it create an identical, an equivalent, but cloned user. See, it just flipped over there. That has identical database permissions, rotated the password, started distributing that one out to my application. So obviously, without doing anything on the app side, it automatically picks that up, automatically starts using it, and because those two passwords existed for brief moments of time in parallel, there was literally no outage, right? All right. So now the code that essentially is behind the scenes there, if you want to get started, one of my colleagues, Jeff, put together a cool workshop. That, again, is up on GitHub. But I really would encourage you, again, as you think about how to drive secrets and long-term credentials out of your environment, explore around Secrets Manager. It's really powerful. Okay. And we're now going to be up to our third and final layer of the cake, right? And I wanted to find like a cool, cheeky quote for this, but I couldn't. But at the end of the day, we do all this work in AWS. We provision all this infrastructure and use all these awesome services to provide apps out to our business, our customers, et cetera, right? And at least in my travels, this is an area where there's a lot of amazing things that we can do in this world that really help us move the bar, but we haven't probably talked about them as much as we need to. Here again, we've got kind of a breakpoint or two different aspects of the topic that I'd have you look at. There's kind of the human to application side, right? How I, as the individual, am logging in. And then in this kind of microservices, service-oriented architecture view of the world, what is very prevalent is the service-to-service as well, right? To where there's no human in the loop. It's just an API calling another API. Now for the humans, the Swiss Army knife that we give you is Amazon Cognito. Right? We'll look at kind of an example here in a second, but this is a service from AWS that started its life as this mobile sync widget thing that needed the notion of identity to do its syncing job, and then very rapidly figured out that identity piece was a really cool little widget. Right? Its kind of superpower is it serves as this normalizing layer for your apps. Your developers don't need to know the goop of SAML or OAuth or how to store passwords for a native user securely and safely, right? But regardless of which types of identities you bring in, it normalizes all of them. So your developers can operate on a standard set of tokens that they can use to access the APIs you build to support the application or AWS APIs. And it also has really clean integration with some adjacent services, right? If you want to authenticate your users with Cognito into the application and just be able to pass that down as authorization of the APIs you build behind API Gateway, a couple checkboxes and you're done. Same thing with ALB. All right, now kind of the basic flow of the way it works is the first step, whether that's a web app, a mobile app, what have you, you kind of use Cognito either through the SDK form or just by hitting the raw OpenID Connect endpoints. You're going to send an authentication request up to your user pool. The user pool is going to take care of all the ugly identity goop. SAML and OpenID Connect and all these wonderful protocols that we know and love rely on all these HTTP redirects and postbacks and metadata and all this stuff. But Cognito is going to abstract that all the way. It's going to take care of all that. And after the user is successfully authenticated, and we return an IDP token, SAML assertion, OIDC, ID token, what have you, back to Cognito, what it's going to do is turn around and again, normalize that into a standard set of Cognito, what are known as user pool tokens, CUP tokens. And these are just JWTs. It's going to return that back to the application. And then if the application needs to access APIs, again, these are your APIs that you've written to support this app that you might have developed with serverless patterns or any other tooling in AWS, you can simply pass that CUP token as the authorization for the user to those APIs. Now, if your application needs to also access AWS services, right, our APIs, S3, DynamoDB, et cetera, the other half of Cognito in the identity space is known as the identity pool. Here, you can take that user pool token that you already had and flip that around through Exchange into the type of credential you need to call an AWS API, which is the STS token. We return that, and then should that same app need to access native AWS services, it just simply passes that STS token, or technically, obviously signs the request, right? It's not actually passed. Okay, so if that is a super quick tour, and we'll see more in the demo of identity for the apps, let's talk a little bit about identity for the machines. And again, this is where we're up at that application layer, but we've got a service. It might be a batch job. It might be a headless API. It might be event-driven computing. It can be just about anything. Historically, if we wanted to do that, one way that was a very common way is we would do TLS mutual authentication. We'd go through all this laborious pain to fingerprint all these things. We'd cut certificates. We'd have to plumb the certificates down. We'd have to write rules in Nginx or Apache on the other end to say like what certificates were allowed to call this other API. it was very doable and was very powerful, but it was a lot of goop. And it was a lot of goop that was really hard to get right. And a lot of customers, that at least the ones I was seeing, were often punting on this whole notion of identity in this way and just relying on network controls to isolate this down. So certainly, I think that there's been some neat work in the industry as of recent with service meshes and other approaches that are given kind of better ways of doing this. But this was generally a pretty painful one historically. Now, how might you do this differently or better in AWS? So if you've got APIs and all of your components purely within the AWS world, you can use the combination of IAM-based authentication and API gateway. So the story starts, like we've seen a couple times throughout the day, where we attach a role to our calling service, and we give that role permissions to invoke an API on the other end. I then just need to configure API gateway for IAM authentication, little checkbox, and then attach some permissions. I can attach permissions either to the principal calling, if everything is within one account, or I can use a resource-based policy and attach permissions to the API if I want to do this across accounts. And then when the service actually wants to call, it just SIG-v4 signs using some pretty standard AWS tooling and code samples. It signs the request, and AWS takes care of all your authentication authorization. By the time the call gets to the back end, you know who it was, but you don't need to do any verification whatsoever. Right. Okay. So now that's a really powerful option because it takes all of who can call what is codified in IAM policies, and we take care of all the credential distribution. We were already doing that. Life is good, right? But that does tend to be a solution that not everybody can use because it implies that the API that you were calling runs behind AWS API Gateway, right? Or Amazon API Gateway. And lots of times, especially as customers are moving, you might be calling APIs on-prem, you might be calling APIs in other places on the broader internet, so on and so forth. The other way to kind of crack this nut, right, is you use the client credentials flow. And this is a standard OAuth flow that Cognito supports. In this case, what we're going to do is we're going to retrieve a client ID and client secret using another AWS primitive, in this case, something like Systems Manager, parameter store. And we're going to go down to Cognito, and again, it's an OpenID Connect provider, right? We're going to execute the client credentials flow. We're going to get back that cup token, and we're going to do standard bearer token authorization over to the API. The really nice thing here is this is exactly how we authenticated the humans to those same APIs before. If you're using API Gateway, it's a couple clicks. If you're not using API Gateway, it's very straightforward token verification, right? It's, again, a very familiar model to developer. And the only kind of twist here is essentially that you're going to need to use the primitives we give you, things like Systems Manager, to be able to distribute those client ID and client secrets down to your apps. So in the interest of time, I'm actually going to combine, I did this the other day, I'm going to combine this demo with the last one. And so we're going to skip forward. But before I do, a couple further, a couple further places to dive further in and explore. The one there on the left is a very hands-on workshop that some of our solution architects put together that drives through great uses of Cognito in all these various patterns. Excuse me, the one on the left is a session they did last year, 60 minutes just on that. The one on the right is that hands-on exercise. Okay, so now at the beginning of the talk, I baited you a little bit with that I was going to take some of these concepts, join them together, and see how we could create something more powerful out of them individually, right? So while I think the ability to do IAM-based authentication to infrastructure is a really powerful pattern, we always want to be mindful to drive persistence out of our environments, right? Like I think it's a good goal to strive to, such that I should always be authorized to connect to that given EC2 instance. But maybe I just want to put just enough of a hiccup in the road to where it's more of a break last operation and less of something I can do at any point because I'm authorized. So let's see how we can combine everything we've done today to achieve something like that. Oh, computer went to sleep again here. All right. Okay, so the first thing I'm going to do in my application here is I'm going to go ahead and log in. Under the hood, I've integrated Cognito with this application, and I've chosen to support two different types of identities. The one on the right would be a native identity, like an identity that exists in Cognito, but I'm going to connect through here to my SAML IDP. And I'm going to log in, right? And this, again, Cognito's doing all the crazy post-back redirect stuff and lands me back in my application. Now, what the identity provider did in this particular case, and we're going to, let's see if we're going to grab my ID token here, just to show you. And I'm going to use this handy little website to explore that a bit. The identity provider, let's see if we can properly find it, provided me with a list of EC2 operator groups, right? This is information that came from the identity provider, and I used a pattern here that's similar to the way we typically do some of the access management for AWS. I did like EC2 operator underscore account number underscore tag group, right? And this is the identity provider saying, I, Quint, am allowed to manage these types of instances, right? Okay, so now before I kind of do, so let's switch out the local identity that I've been using to this point on my local machine, and let's go in, and instead of my bounded developer, I'm going to choose a read-only user in that same account. I'm going to list my instances. Right? And I'm going to show you just that I clearly cannot, by default, using this credential, connect to that one that I showed before. Right? So I've taken away the persistent ability for me to connect to that. The identity provider said that these were the instances I was allowed to connect to. And I'll show you kind of how this looks architecturally in a second. But what then as the story goes, now something breaks. The operator needs to get to that instance that they don't have persistent access to. They come to the app, they log in, the identity provider says what instances they're allowed to connect to. They hit the one they're interested in. It gives them a time-bound token, 15-minute long token that's scoped exactly to the instance they want to connect to. It gives them easy ways to drop that into their shell, and it gives them a nice, handy cheat sheet on how to connect. So literally with almost no speed bump, I took the same notion of authorization, right? And I moved that upstream to the identity provider and gave the user the same way to achieve the same functional thing, connecting that instance, but I just put that little bit of friction in. And let's flip back over and we'll see why that's powerful, all right? So here we are, it's go time, right? I want to connect to my failing machine. I go to my break glass portal. That is authenticated and authorized by Cognito. Goes over to the corporate identity provider, gets that list of accounts and tag groups that I'm allowed to manage. And it's going to return that information encoded in that token that I showed you back to that front-end application. I then built again, we kind of talked about it in the beginning, a custom broker. I built some notion of a serverless custom broker that has two API methods. One is list my instances, right, where I pass that Cognito user pool token with the claims. I use some S3 APIs, or excuse me, some EC2 APIs to understand the instances, and I get back that list. And then the next one is I say which instance I'm interested in connecting to, right? And then the really neat thing happens, and this is the special sauce, is I can send notifications. At this point, I could implement two-man rule. I could implement a cooldown period. Because I've put just that little bit of hiccup in there, I can do all sorts of telemetry, instrumentation, business rules, etc. But once those all pass through, I then obviously just go to STS, grab that temporary token. Again, it was uniquely scoped to the instance I wanted to connect to, and it was time-bound, and I returned that back to the user, and then they were able to connect just like they would before. Okay? And now, you might be saying, well, that seems like super complicated. That was the back end of that was 140 lines of code. Now, I was a little liberal. I didn't count white space, and I didn't count my comments. And if you haven't played with it before, the Chalice Python framework is an awesome way to build your first API. I'd highly encourage you to check it out. But these are very approachable things. And I hope to get a blog out for this very recently that'll put the code in your hands more directly. So now that, to me, is the best cake of all, right? My wife happens to be, first and foremost, an awesome engineer, but she's also an awesome cook. This is her icebox mocha cake, which is a recipe she did grab from the internet. I encourage you to look at it too. But this is one of those great cakes, right? All the flavors meld together, super delicious. And if nothing else, on your way home, check that out. To me, that pattern is really... it's Friday. I've stumbled over my words. So with that, thank you. I hope you guys had an awesome week. I appreciate you coming by. Yeah.